All right, are you confused yet? Like how it is that we're supposed to apply this integration by parts? Of course you are, because we haven't even looked at an example. All right, so I'm going to give you a couple of other tips on how to choose the appropriate thing for you and the DV so that we can actually carry out integration by parts. And I'm going to do so with a mnemonic device. Mnemonic device, remember, it's just, hey, here's like a word or something that's going to help us remember what order something's going to go in or something like that. So usually integration by parts happens when you're taking an algebraic function and you're multiplying it by a transcendental function. If you don't remember what transcendental means, it means like super, super irrational. Think exponential, think trigonometric and inverse trigonometric, okay? Right? And again, it is a product of two things for your original integral, right? And we gotta try to switch it out for something that's far simpler. And we're going to use this mnemonic device to do so. It's called Lipit. On the left-hand side, you have your u. It corresponds to your u dv. On the right-hand side, you have your dv, which of course corresponds to the dv in your original integral. The closer you are, or the further to the left that you are in this little mnemonic device, you're going to choose that function to be your u. The further to the right you are in this Lipit thing, you're going to choose that portion to be your dv. Well, what do all of these letters stand for? Obviously, we've got L to be the logarithmic function. I is going to be, you guessed it, inverse trig. P is going to be power. Power is going to be polynomial. It's also going to be root because you can think of it as to the 1/2 power, something like that. E is exponential. And then finally, T for trigonometric. Again, the further to the left that you are on this continuum, you're going to choose that part of your function to be the u. The further to the right, you're going to choose that part to be dv. All right, next up, we're going to organize the integration by parts with a little box. Okay, so in this little box, this is what it's going to look like here. And along this red diagonal, this is our original integrand. We're going to put our u in the first red box, and then the dv eventually is going to go in the second red box. So the original integrand is going to be along the red diagonal, and as you're about to see, the new integrand, the v du, is going to be on the blue diagonal here. Okay, so to get the next step here, we're going to differentiate our u function, whatever it is, in order to get du. And that du, of course, that's the thing that's going to go in the second integral right here. Okay, now we're going to take the dv part and put it in the second red box here. And in order to get the v that we need for the second integral, we need to integrate, right? And now what we can see is along the red diagonal, we have the original integral. And along the blue diagonal, we have the new integral. And hopefully, as I've said 14,000 times, this new integral is the one that's simpler, far simpler than the original one, and it's going to be easier to integrate. And then remember that the actual answer here is uv, which is along the top of this box, uv minus the antiderivative of v du along the blue diagonal. All right, so let's take a look then at our first actual example. We're going to take the antiderivative of x e to the x dx. So you can see that we have an algebraic function, which is just x multiplied times a transcendental. It is a product of two things. And now, when you're first looking at this, you might think, well, can I do this by u substitution? And no, you just can't. You might try letting u equal x, but then that just switches out your x's for the variable u, and you're back exactly where you started. Again, we have a product of two functions. We're going to use some integration by parts, so this is how this is going to look. So I'm going to write a couple things down. The first thing I'm going to write down is the integration by parts little formula. So I'll write this right up at the top. So we have the integral of u dv is equal to uv minus the integral of v du. And then I'm also going to write over here on the left-hand side, Lipit. Remember our mnemonic device that's going to help us choose what part should be u and what part should be dv. So the further to the left that we are, that's going to be our u portion. And the further to the right that we are, that's going to be our dv portion right? And it's just exactly like what we have right here in this original one, u and the dv. So we have x. X is a power or a polynomial function, and this is right here in the middle. Let me just kind of highlight that. So we have the p, and then e to the x. That obviously is exponential. Maybe this one gets green or something. So you can see our order right here, right? From our little mnemonic device, the p is closer to the u, so it should be our u function, and the e is closer to the dv, so it's going to be the dv function, okay? And then also, remember that we're going to take the derivative of this x part, and so when we take its derivative, it's just going to be 1. It's far, far simpler, and that's one of our goals here. So I'm going to write that u is equal to x, and now I need to differentiate and find du. That should just be equal to 1 dx. Okay, now I choose the other part, so this was my x part, my u part, I should say. And then the second part is going to be my dv. So I'm going to start it at the bottom. dv is equal to e to the x dx. And now in order to get v, essentially what I need to do is integrate this, right? I've got to integrate both sides of this. So v is equal to, what's the antiderivative of e to the x? It's also e to the x. Sure, it's e to the x plus c, but don't worry about the plus c until we're all done with the problem. Okay, so then again, our formula here is u times v minus the integral of v du. U times v is across the top of our box that's right here. I know it doesn't look like a box, but you know the original one, we wrote it in a box like this. All right, so it's u times v. Actually, here, let me write this down. So integral of x e to the x dx is equal to x e to the x. Again, that's u times v minus the integral of v du. So this is the blue diagonal from this little organizational box here. So e to the x dx. E to the x dx. And now you can see that the integral that we started with has a product, but the new one no longer has a product, and we can easily take the antiderivative of this. So I have, just bringing the first part down, e to the x times e to the x minus, now the antiderivative of e to the x is just e to the x. And since we did take an antiderivative, we'll go ahead and throw in a plus c. Hey, remember when we first learned to take antiderivatives? What is the technique to check to see if we got this right? It's to find the derivative. So let's take the derivative with respect to x of exactly what we had, which is x e to the x minus e to the x, whoops, and then plus c. Let's take its derivative and confirm that this is what it should look like when we're all done, okay? All right, so on the first part, I'll have to use the product rule. So that's the derivative of the first, which is just 1 times the second, e to the x, plus the first one, x, times the derivative of the second one, e to the x, right? And now, term by term, take the derivative of these two pieces. Derivative of minus e to the x is minus e to the x. The derivative of c, a constant, is just 0. And then we can see that the e to the x is canceled right here, leaving us with x e to the x. And there you have it. That is identical to the original integration, integration by parts. So just kind of a recap here with the lipit. What we did is we chose the x to be the u because it was further towards the left, closer to the u. Also, its derivative was far simpler, so it made sense to choose that one as the u. And then the e to the x as an exponential is further to the right in the little mnemonic device, so we chose that to be the dv. Whenever we go to do integration by parts, take your u and take its derivative, take your dv and take its antiderivative. When you're all done, if you're not quite sure, or just to gain a little bit of confidence, you can always take the derivative of your answer, and you should get your original integrand back.